This is class number 7 of Computing Molecular Biology 1. I am Andres Aravena. In the previous class, we discussed how R can be used as a typical calculator. We can write a formula directly in the prompt, and R will respond with the result. We can also use function that we write with the name followed by parentheses. So in R, functions have always the same shape. The function has a name, and the input of the function is inside a parenthesis, a round parenthesis. Some functions sometimes can take more than one input. In that case, the inputs are separated with a comma. For example, the logarithm of 3 in base number 2 is written like log of 3, 2. The order is important. So, if R is a calculator, what other buttons can we use? Today we are going to talk about the memory buttons. We are going to learn a new language, exactly like when we learn to speak English. The basic rule of this language is each phrase in a program is an order, the same way that we say, come here. We give commands to the computer, we order the computer what to do. The phrases in general, all phrases are made with nouns, verbs, and adverbs. Today we will focus only on the nouns and one verb. The verb that we use today is assign, that is represented with an arrow. The nouns are names of objects. In general, every time we want to talk about an object, we need to give it a name. If we don't give a name, we cannot talk about an object. To store the result of a computation in the memory, exactly like using the M in the calculator, we use the arrow with the format that we see here. In the first line, we give a name, then arrow, and the value that we want to store, and in the second line, we ask what is the content of this variable. With one arrow, we assign, and there is no output. Without arrow, we ask what is the content and we see what is the value. We can only look at the variables that already exist. If we ask for a variable that doesn't exist before, we get an error. And the same happens if we use the wrong case. If we use big letters instead of small letters, we will get an error. So we have to be careful. If we use big letters, we have to use always big letters. If we use small letters, always small letters, because they are different. We have some freedom to choose the name. It is good to use short names for things that we use a lot. For important things, it's wise to use longer names. You can use underscores to separate part of a long name, or you can start every word with a capital letter. These are two standards that people use. But you cannot put empty space inside. You have to be coherent. If you use underscores, use always underscores. If you use big letters, use always big letters. Be coherent. You cannot use space inside a name. You can start with any letter, and then you can follow letter, number, dots, or underscore. Don't use dash in the name. Don't use space in the name of a variable. The assignment process assigns new values to an old variable. For example, we have this variable a that we created previously and has the number 2. If we assign a plus 1 to a, we take the value of a, we add 1, obtaining 3, and we store it in the same old place. So we replace the old value, and now a has the value of 3. If we do it again, we take the old value of a, we add 1, we store in the same place, and now a has the value of 4. So we are essentially updating the value of the variable in every step. These formulas that we put in the right hand side can be more complex than simple addition. We can use any kind of formula, for example, a square root or any function that we want to use. We can also say, this is an alternative, we can also use the equal sign that is very common in other languages. But in R it's not recommended because the arrow is more clear. It shows clearly that there is a value going to one place to be stored. The other thing to keep in mind is an assignment is not an equation. So if we write this expression here, it doesn't make any sense if you think that is an equation, because you are saying that a value is equal to the same value plus 1. This has to be understood not as an equation but like an assignment. Take the old value of A, add 1 and store in the same place. That is confusing. That is why I prefer using an arrow. Assignments are not an equations, are commands to put values inside a variable. Now, question. What will happen if we follow this step? You take A, assign the value of 3, then you take B and assign 2 times A, then you have A and you assign a new value. What will happen with B? Will it be 6? Will it be 10? This is an exercise for you. Sometimes variables exist but they don't have a value that we know. For example, we ask someone a question and that person doesn't answer. In that case, we have a particular symbol that is represent a missing value or not available value. The text NA with big letters represent a variable that exists but whose value we currently don't know. We may know it later, but in this particular moment we don't know what it is. In summary, the arrow is used to store values in the memory. With one arrow we assign and there is no output. Without the arrow we look at the content of the variable. Now, from the previous class we also learned how to write Markdown. Now we want to mix Markdown and R. You remember that essentially Markdown are a text file that we can edit with a text editor. Every paragraph is separated by an empty line. Every section is separated by a heading and the heading starts with hash and a space. Lists can be made using the plus sign or the minus sign or a star and a space. And important for us, computer code is marked with 3 backticks at the beginning and at the end. Now, if these 3 backticks are followed by curly brace or curly brace, like this expression, then the content of this code is executed and the result is inserted in the document. We get this figure. The input is shown with one style and the output is shown immediately after. This is the key idea of R Markdown. Mixing code and text will help us to write documents that adapt to the data. All tables and figures will correspond exactly to the data available, and if you get new data, the document will change. R Markdown reports are replicable, and that is essential in science.